So the title of this talk is Einstein Absurd. Einstein said things about his theory of relativity, both special and general, where later workers on relativity said something else. So let's look at an article dealing with that. The article is from this popular science magazine called Discover. It's got a special issue for Einstein. And this is the article entitled Patently Absurd. And the article says, Einstein, creator of relativity, godfather of quantum physics, bender of space and time, had a little problem that dogged him all his career: lack of vision. It may seem an unlikely charge to levy against the greatest scientific visionary of modern times, but even Einstein had his limits. Despite the extraordinary intuitive leaps he made, he often found himself unable to see what lay beyond his basic insights. As a result, many of the most stunning ideas associated with the theory of relativity were developed not by Einstein but by other scientists interpreting his work. In quantum physics too, Einstein set out the fundamental concepts but initially failed to recognize where they would lead, and in his final grandest search for a theory that unified all of physics, he simply never moved far enough beyond the math and science he had learned during his student years. And so I'm making a note of developed not by Einstein but other scientists interpreting his work. And so i.e. what came later was not necessarily endorsed by him, and it was an interpretation of what Einstein was saying. And in some of my other videos I point out that that interpretation I think is incorrect. So they were interpreting what Einstein was saying and getting it wrong, in my view. So the article carries on. More surprising, Einstein resisted the full implications of his work even after those implications were pointed out to him. Repeatedly sought to undercut many of his colleagues' interpretation or to explain them away because they seemed too absurd to be true. These rejections recall the words of Arthur Eddington, a brilliant British physicist and one of Einstein's most tireless champions. And he's quoted him saying, "Not only is the universe stranger than we imagine, it is stranger than we can imagine." End of quote. One of history's most expansive minds was no match for the boundless oddity of nature. And so my comments are, well, making note of what is said here, undercut many of his colleagues' interpretations, i.e. he disagreed with his colleagues' interpretations of what he was saying. And I also note the other thing said, they seemed absurd, hence the title of this video, Einstein Absurd. And the article carries on. Almost as soon as Einstein completed his 1905 paper introducing the special theory of relativity, he found his ideas taking on a life of their own. That paper spelled out how an observer's motion through space affects his motion through time. And to someone travelling nearly the speed of light, time slows to a crawl. I'm sort of like, think this sort of thing needs further elaboration, but letting it go for the moment. But it said nothing about treating time as a fourth dimension in a continuum of space-time, i.e. his 1905 paper on special relativity didn't talk about time as fourth dimension. The concept which today's students learn as quintessential Einstein was actually the work of German mathematician Minkowski. And so it was sort of an update to Einstein's relativity to bring in what Minkowski was saying. And Einstein's reaction was, as it says, Einstein was at first nonplussed by Minkowski's elaboration of his theory, shaking it off as superfluous elucidation. Only years later did he recognise space-time as integral to special relativity. So adding Minkowski's time as the fourth dimension and the space-time diagrams was an update to Einstein's relativity, his special relativity. And so the article carries on and to the grander general theory of relativity that followed, i.e. Minkowski's space-time diagrams led to that idea where if instead of having straight coordinates you could have them curved. After Einstein published the definitive version of general relativity in 1916, he again found that his theory was full of oddities that he neither expected nor accepted. Just months later, Schwarzschild, a 42-year-old physicist in the German army during the First World War, successfully applied Einstein's abstract equations of space and time to a realistic physical problem, modelling the geometry of space surrounding a star. His solution impressed Einstein, yet Einstein expressed one deep concern. Schwarzschild's calculations showed that if the mass of a star were compressed into a small enough volume, Einstein's equations went haywire. Time froze, space became infinite. Physicists called that a singularity, a place where the normal laws of nature break down. Schwarzschild had stumbled onto the first clue that black holes might exist. So what happens with the equations of Einstein's general relativity? They break down at the singularity, and really you should be having something other than a black hole with its singularity, because in the singularity the laws break down. The equations don't really make sense, they just break down. The article continues. For years no one paid much attention to Schwarzschild's discovery, but in 1939 Einstein attempted to disprove the annoying singularity. He argued that a star could not exist under the conditions described by Schwarzschild because the material within it would have to reach orbital velocities equaling the speed of light, and that would be the speed of light c in a vacuum. But Einstein assumed that the star had to remain stable, whereas the universe is full of objects that explode or collapse violently. In that same year, Oppenheimer, the physicist who would soon direct the Manhattan Project, which was building the atom bomb, and one of his students, a student of Oppenheimer, showed that highly massive stars could implode under their own gravity, getting denser and more extreme until their gravity trapped even light. That is exactly how astronomers now believe most black holes form. So what I note from that is Einstein wanted to get rid of this idea of the singularity, but those who came after him kept it. The article then talks about the cosmological constant, but I will pass on that because I think I've dealt with that quite a few other times. So moving on, the article says Einstein's problem with relativity were nothing compared with the passionate manner in which he rejected the legacy of his ideas in quantum physics. In the early years of the 20th century, when most physicists still thought of light as a wave, Einstein was one of the few who believed in particles of light, or photons, and he tried to visualize how light could have both wave and particle aspects. During a 1909 lecture in Salzburg, he said, and this is quoting, I more or less imagine each such singular point of light as being surrounded by a field of force which has essentially the character of a plane wave. In 1921, he won a Nobel Prize, his only one, for explaining the photoelectric effect, in which particles of light eject electrons from the surface of a substance. This is the principle exploited in solar cells today. The article carries on. Despite his early advocacy of the quantum nature of reality, by the 1920s, Einstein had begun voicing serious doubts about the theory. He objected to the seeming randomness of quantum mechanics. And my comment on that is Einstein didn't like the direction that quantum mechanics took when it brought in such things as Heisenberg's uncertainty. The article then carries on. It says, he was famously asserting that God does not play dice with the universe. The statistical nature of reality at the subatomic level is now well established. However, Einstein was wrong. And so my comment on this is the physics establishment just choose to believe in quantum mechanics and to believe Einstein was wrong about it. Getting a proper reason why they choose to believe this is difficult. They don't seem to want to answer why they've reasoned that way. They just want to say Einstein was wrong without going into details. But the article does get on to part of the reason why Einstein didn't like quantum mechanics. And so this is what the article says. A fundamental reason for Einstein's distrust of quantum physics concerned a startling property that he recognized before anyone else. It allows for instantaneous interactions between two objects, no matter how far apart they might be. In this case, his insight was correct, but his understanding missed the mark. And according to the article, Einstein didn't like instantaneous interactions. And then it's highlighting the comment, his understanding missed the mark, and that is just establishment choosing to dismiss Einstein's point of view on the subject. And I want to pass on this issue of instantaneous interaction with its connection to the Einstein-Podolsky-Walton paradox, because I think I've dealt with that a bit better elsewhere. The article carries on. We now know that Einstein's efforts to find an all-encompassing unified theory were doomed because he knew nothing about two fundamental forces within the nuclei of atoms, forces that came to be understood only after his death. Yet the search for a theory that would unify all of physics continues to occupy thousands of researchers around the world. The spirit, if not the style, of Einstein's quest for a unified theory lives on. So my comment on that is Einstein was trying to unify electromagnetism with gravity, and that would have been a good start to a unified theory, even though he didn't know of what the other two forces were, which are called the strong and the weak forces. Unified theory attempts continue today with such things as superstrength theory. The article carries on. It's not that other people were more brave in accepting quantum mechanics, they just didn't see what was coming. What was coming was instantaneous action at a distance. We now know that Einstein's efforts to find an all-encompassing unified field theory were doomed because he knew nothing about two fundamental forces within the nuclei of atoms, forces that came to be understood only after his death. Yet the search for a theory that would unify all of physics continues to occupy thousands of researchers around the world. The spirit, if not the style, of Einstein's quest for a unified theory lives on. Still, Einstein missed connections serve as a warning to today's physicists. Are they too oblivious to the limits of their vision, working with an incomplete understanding of some fundamental aspect of nature? And Rovelli says, yes, it's perfectly possible. If you look at the history of physics, almost every epoch has the feeling that we know everything now. I think that we don't know is probably huge. We are still far away from knowing all the ingredients. End of quote. The article carries on. And I'm highlighting again what Rovelli was saying. I think that Rovelli is just trying to dismiss unified theory attempts from other epochs. Specifically, before Einstein, there was a unified theory attempt. See, for instance, this paper from a historian of physics science, who in his paper talks about the vortex atom, a Victorian theory of everything, meaning a unified theory. Article carries on. Perhaps if Einstein had lived longer, he might have come to accept quantum mechanics, making peace with his most unwelcome scientific prodigy. It's difficult to say because Einstein changed his mind so many times on so many subjects, Rovelli says. And Rovelli carries on to say that's a sign of a great scientist. A great scientist is not someone who believes his own ideas, it's somebody who does not believe his own ideas. He's ready to change his mind. What Einstein did was bring back science to its true soul, which is to change our view of the world, not just explain things. Einstein reminded us that what we don't know is much more than what we know. End of quote. And so I'm emphasising this bit. Einstein changed his mind so many times. That makes him difficult to follow because he just ends up with a collection of changes of mind. He doesn't stick to one thing. And I think that's a total mess. Rovelli thinks, oh, that's good. Einstein changes his mind, but you've not got no reasoning behind why you've got these changes of mind. You've just got random changes of mind. Finished. Thank you.